Today we are going to learn about implementing real-time model monitoring with Prometheus. We will dive into setting up Prometheus for monitoring, configuring metrics, and integrating with Grafana for visualization, equipping you with skills to ensure model reliability and performance.
Prometheus is a powerful, open-source monitoring solution designed to handle real-time metrics collection and alerting. It is particularly well suited for cloud-native applications, due to its multidimensional data model and time series database. One of the key benefits of Prometheus is its ability to perform real-time monitoring, allowing you to quickly identify and resolve performance issues as they arise. This is crucial in maintaining the reliability and effectiveness of your models. Prometheus also integrates seamlessly with Grafana, a leading open-source analytics and interactive visualization solution, enabling you to create detailed dashboards that represent your data visually. With its robust community support and extensive documentation, Prometheus has become a go-to choice for developers looking to implement monitoring solutions that can scale with their applications.
The first step in implementing real-time model monitoring with Prometheus is setting up the Prometheus server. Start by downloading the latest version of Prometheus from the official website. Once downloaded, extract the files and navigate to the directory. The core configuration of Prometheus is done through a YAML file, typically named prometheus.yml. In this file, you will define the global configurations, scrape intervals, and job configurations. Scrape intervals determine how often Prometheus will collect data from your model endpoints. For effective monitoring, ensure that Prometheus has network access to your model's endpoint URLs. This might require setting up firewall rules or network proxies. After configuring the YAML file, you can start the Prometheus server by executing the Prometheus binary. Verify that the setup is correct by accessing the Prometheus UI through a web browser. This interface provides a wealth of information on data collection status and available metrics. Testing the setup is crucial to ensure Prometheus is retrieving data correctly from your models, which lays the foundation for effective monitoring. Once Prometheus is up and running, the next step is to configure it to track specific metrics from your models. To do this, you need to define what metrics are important for your use case. These could include inference times, error rates, or throughput. To expose these metrics, you need to modify your model's code to include a metrics endpoint. This is often done using Prometheus client libraries available for various programming languages, such as Python, Java, and Go. These libraries help you expose metrics in a format that Prometheus can understand, known as the exposition format. After integrating the client library into your model code, metrics can be exposed at a new endpoint, typically /metrics. You can test this endpoint using tools like curl to ensure that the metrics are being exposed correctly. This step is crucial as it allows Prometheus to scrape the metrics and store them for analysis. Properly configuring metrics exposure ensures that you have a detailed view of your model's performance, enabling you to make informed decisions about improvements and troubleshooting. Monitoring alone is not sufficient, you also need a mechanism to alert you when something goes wrong. That's where Prometheus Alert Manager comes into play. Alert Manager handles alerts sent by client applications such as the Prometheus server. To create alerts, you need to define alerting rules in your Prometheus configuration files. These rules specify when an alert should be triggered based on the metric values. For instance, you might set an alert to trigger if your model's error rate exceeds a certain threshold. Once an alert is triggered, Alert Manager can send notifications through various channels, including email, Slack, or PagerDuty. To integrate with communication tools like Slack, you need to configure a webhook URL in Alert Manager's configuration file. After setting up alerting rules and notification channels, it's important to test the entire alerting pipeline by simulating metric anomalies and ensuring alerts are triggered and delivered correctly. This proactive approach ensures that you are immediately aware of any issues affecting your model's performance, allowing for swift intervention. To fully leverage the power of Prometheus, it is beneficial to visualize your metrics using Grafana. Grafana is a popular open-source platform for monitoring and observability that allows you to create interactive and visually appealing dashboards. Start by installing Grafana on your server. Once installed, log into the Grafana interface and add Prometheus as a data source. This involves specifying the URL of your Prometheus server and configuring access settings. After successfully connecting Grafana to Prometheus, you can start creating custom dashboards. Grafana provides a variety of panels that allow you to represent data in different formats such as graphs, tables, and heat maps. You can customize these panels to focus on specific metrics that are critical to your application's performance. Additionally, Grafana allows you to share these dashboards with team members, facilitating collaboration and collective troubleshooting. By visualizing data, you gain insights that are not immediately apparent from raw numbers, helping you make more informed decisions. Once your Prometheus setup is running smoothly, it's important to follow best practices to maintain its performance and reliability. Regularly updating Prometheus and its dependencies is crucial for security and functionality improvements. As your data grows, consider archiving old data to conserve storage space while still retaining valuable historical information. For larger deployments, Prometheus Federation can be used to scale your monitoring setup. This involves configuring multiple Prometheus servers to scrape different sets of targets, and then aggregating the data into a central server. Documenting your configurations and any changes made is equally important, as it provides a reference for troubleshooting and future modifications. Additionally, optimizing scrape intervals is critical for balancing system load and data granularity. By adhering to these best practices, you ensure that your Prometheus setup remains efficient, scalable, and easy to manage over time.
Even with a well-planned setup, you may encounter integration issues when using Prometheus. One of the most common issues is incorrect configurations in YAML files, which can lead to data not being scraped or alerts not firing. Checking the syntax and configurations in these files is a good starting point for troubleshooting. Additionally, network issues such as incorrect firewall settings or proxy configurations can prevent Prometheus from accessing model endpoints. It's also important to ensure that the client libraries used in your code are compatible with your version of Prometheus. The Prometheus console is a valuable tool for real-time debugging, as it allows you to explore metrics data directly and identify issues. Familiarizing yourself with common error messages in Prometheus logs can also aid in quickly resolving issues. By systematically troubleshooting and addressing these issues, you can maintain a robust monitoring solution that supports your model's performance.
As your application grows, so does the need for a scalable monitoring solution. Prometheus is designed with scalability in mind, but there are inherent limitations to be aware of. For large-scale deployments, implementing Prometheus Federation is a common strategy. This involves using multiple Prometheus servers, each responsible for scraping a subset of targets, and then aggregating the data. For even greater scalability and long-term storage, the open-source project Thanos can be integrated with Prometheus. Thanos extends Prometheus by enabling highly available Prometheus setups with long-term storage capabilities. Optimizing resource allocation, such as CPU and memory, for each Prometheus server is critical to ensure performance under load. Planning for both horizontal scaling, adding more instances, and vertical scaling, increasing resources of existing instances, is essential for maintaining system performance as the number of metrics and targets grows. By implementing these strategies, you can ensure that your Prometheus deployment scales effectively to meet the demands of large-scale applications.
In conclusion, implementing real-time model monitoring with Prometheus is a powerful way to ensure the reliability and performance of your applications. We covered the fundamentals of setting up Prometheus, configuring it to track critical metrics, and integrating it with Grafana for enhanced data visualization. We discussed best practices for maintaining your setup, troubleshooting common issues, and scaling for large deployments. Real-time monitoring is vital for swiftly identifying performance issues, and Prometheus offers a robust solution that grows with your needs. We encourage you to explore further and continue learning about advanced Prometheus features to optimize your monitoring strategy. Thank you for joining us in this session.